Hi, welcome to this video. I'll be explaining about the Carnot engine and a Carnot cycle. It's pronounced as Carnot. There are a few parts in this arrangement. A cylinder, which is in blue color, which holds the gas in the enclosed space. A piston of yellow color, which can slide in and out without any friction, so there is no friction between the piston and the cylinder walls. And there is a burner to provide the heat as per the first law of thermodynamics. Now we have fired up the gas and the piston is moving out, and the gas does work on the piston. The piston moves out to its extreme position and then it moves back, it returns to compress the gas. So the expansion and compression constitute one cycle. So this Carnot engine is a cyclic process engine. Obviously, you saw that the fire was switched off during the compression. There is no need to provide heat when somebody is doing work on the gas. The heat is required only when the gas has to do work on the piston. So in this front view, we have to note three things at all times: pressure, volume, and temperature. That's it. There aren't too many things to note. So the front view enables us to note the volumes at the starting point and at the intermediate important points. Let's start with the beginning. So the piston is at a particular position, and let's note its volume. So the volume of the gas that is contained in the cylinder, and from here on the piston will be moving out and coming back. We fill the gas and fire it up. The piston has moved out to an intermediate position from its starting point 1. The intermediate position has a mark. This particular part of the expansion is called the isothermal expansion. Isotherm means temperature is constant. Heat is still being provided to the gas. The piston now has moved out to its extreme position marked as 2. And the second step of expansion is called the adiabatic expansion. Means that there was no heat exchange to the gas or from the gas to the surroundings. So note the pressure and volume. The pressure has decreased, the volume has increased. Now this cylinder is experiencing a compression. The piston has moved towards the end. So there is a compression called the isothermal compression. The temperature here remains constant. Obviously, the burner is switched off. The last and final stage of compression is the piston coming back to its starting point. The gas is now fully compressed, the burner is still off, and the pressure has of course increased back to its starting point, and the volume has decreased to its starting point. The whole system is back to the starting point called 1. So it's obvious that the Carnot engine has a combination of isothermal and adiabatic. Now let's look at the graphs. So the most important graph is the PV graph. The area under this graph gives the work done. So we start with an isothermal expansion, then the blue colored one is the adiabatic expansion. The piston has now moved out to point 2. The piston now compresses, that's an isothermal compression, and the piston compresses further and you get an adiabatic compression shown in blue color. Let's look at it again. So these are the four things that are happening to the gas. So while it's obvious that it's a cyclic process because the graph came back to the point from where the graph started, it's not so obvious that it's a reversible process too. So in this case, as I said, there is no friction between the piston and the cylinder walls, and there is no viscosity and so on, and the piston moved so very slowly. It's called a quasi-static process because of the very slow movement of the piston.